In this video, we're going to be introducing the concept of an arithmetic sequence. And so we know sequences, of course, are these sets of numbers that come in order, I guess you could say. And we know that we have like a first term. We typically use lowercase, like A or B to indicate a sequence here, or whatever letter you want to use. But with subscripts to indicate what term you're at. But we say the sequence is some list of numbers in order such that it has a first element and a second element and so on and so forth. But arithmetic sequences are such that they have a common difference between the terms, okay? So basically that's fancy talk for if you were to find the distance between each of the terms here, we call that a difference or a distance between them, then it would be a constant. So basically what we're saying is these are sequences, A1 through AN, or on forever and ever if you'd like, such that there's a number D that we call the common difference, and we say that D is equal to A2 minus A1. So that'd be like this term here minus this term here. Or A3 minus A2. That'd be like A3 minus A2, or A4 minus A3. In general, what we want to basically list here is this. We say D is the common difference, is what we refer to this as, the common difference. It's a very important number. And we say that D is always equal to A sub n minus A sub n minus 1, which is, kind of a general way of saying that the common difference is basically you take a term and you subtract off the term right before it. So in other words, what we're saying with arithmetic sequences is that there are these sequences where the distance between numbers are the same thing. So for instance, we are adding the same common difference every time onto each number to get the next number in the sequence. So I could make one of these up. I could say 2, 5, comma, I suppose it'd be 8, 11. We say what would come next. I'm, extremely confident that 14 would come next in the sequence, but the reason why is because this keeps going up by 3 every time. So let's talk about this common difference very quickly. I just want to calculate this, but we say if D is equal to A n minus A n minus 1. And this would basically say if I wanted to find the common difference, what I could do is I could take any term and I can subtract off the term right before it. So I'd say 8 minus 5 in this case gives me 3. So the common difference here would be 3. And this would basically tell us that you have some sequence that's going up by 3 every time. So it would be an arithmetic sequence since it has a common difference. So what we're going to do down here is this. Basically, we're going to determine whether these sequences are arithmetic or not. And then we're actually going to calculate the common difference. So we're actually do this in the other order. We say, will this first sequence here be arithmetic? So the question is, I don't know, is it increasing or decreasing by a constant difference every time? So let's see here. If we took 11 minus 7 here, 11 minus 7, we would get 4. And if I were to take 15 minus 11, I'm just saying, not that I have to write this out here, but we get 4. And if I were to take 19 minus 15, so 19 minus 15, we keep seeing that we get this 4 right here. So what I'm going to tell you is this is an arithmetic sequence where our common difference is equal to 4. That is what it is increasing or decreasing by every time. Okay. You'll notice here that I wrote a rule for the nth term. So we have the first term, we have the second term, the third term, the fourth term, but we would say this is the nth term. And one thing I do want to point out is this. If something is arithmetic to begin with, you get this thing that, as a function, if you were to write this as a function, oops, that's not 2x, it'd be 4x plus 3. It is a linear thing. So, and by the way, our common difference is kind of like our rate of change, is our slope. So keep this in mind. We say you can identify arithmetic things by looking for linear nth term rules. So we look at this next one here, and I say, well, look at the nth term rule already. This looks like a line to me where this would be our b, and this would be like our mx if we were talking about a function. But let's talk about, what would the common difference be here. So interestingly enough, we'd actually have to take negative 3 minus a positive 2 here, and we would find out we get a negative 5. And if we were to take a negative 8, this is important, negative 8 minus a negative 3, you would see that you actually would add on a positive 3 and you get a negative 5 still. So yes, the common difference here is negative 5, and I do want to tie this into the fact that this is a very linear looking thing, but that would correlate to like a slope situation if you're talking about this. So now, is this one an arithmetic sequence? Fractions. Okay, so here's the deal. I know that I have to take a term and subtract off the term before it, and I'm probably going to have to do this twice. So I'm going to choose two very convenient terms to work with. How about this? I say, well, 5/4 minus 1. And I may have to do some side work. 5/4 minus 1 whole is the same thing as 5/4 minus 4/4, which is a fourth. So, is the common difference a fourth? That's the question right now. And we're saying, well, I don't know, I need to check 3/2 minus 5/4 as well. So this would be, I think, 6/4 minus 5/4. And you know what, I think at this point we can say that I'm pretty confident that the common difference here is a fourth. So what we're saying is we have a sequence of numbers that's increasing by 1/4 every single time. That's what it's doing. Whereas this one up here was decreasing by 5 every time, okay? So let's go ahead and take a look at, and by the way, this is a linear rule. We could write this as 1/4 n plus 3/4. So this looks very linear as well. This does not look linear for the rule for the nth term, but we're going to find this out because what I see here is this. I say, well, from 4 to 1, what did it change by? Without having to calculate 4 minus 1, I suppose we could just say it changed by 3 in terms of an addition sense. We'd say up here it went by 5. And up here it's going up by 7. And the next one, it goes up by 9. This thing is not arithmetic because it's not got a common difference amongst all of its terms. So what we would say is not arithmetic. But this is how we identify arithmetic sequences. In the next video, we're going to talk about the general form of their rules. Cheers.